Hello viewers, a good day to you all. Today, what I bring before us is polygons and their interior angles. Polygons and their interior angles. Interior angles are important concept in mathematics, let me put it that way. Now, you would have been hearing stuff like sum of angles in a triangle equals 180 degrees. It's a well-known fact. Sum of angles in a quadrilateral equals 360 degrees. What is a quadrilateral? A quadrilateral is a plane figure with four sides. It can be a square, it can be a rectangle, it can be a parallelogram, it can be a rhombus, also known as diamond. It can also be a trapezium. Any four-sided plane figure that you can think of, as long as it has only four sides, the sum of the interior angles will be always be equal to what? 360 degrees. Now, what do you mean by interior angles? Even though they don't normally call sum of angles in a triangle, they don't call it interior angles, but they always say sum of angles in a triangle. But it's actually supposed to be sum of the interior angles of a triangle equals 180 degrees. That's the right statement to use for it. Now, what do you mean by these interior angles? Now, you can see this is a triangle actually. And this is one angle inside, this is another angle inside, and this is another angle inside. So how many angles are we having inside a triangle? Of course, three angles. So these angles inside are the ones we call interior angles. So some of these interior angles in this triangle has to be equal to what? 180 degrees. And of course, I indicated the interior angles with what? Letter A, letter B, and letter C. So we have A degrees plus B degrees plus C degrees equals what? 180 degrees. So that's what we mean by what? Interior angles. And this is a quadrilateral. It may not be a perfect square, but it's actually looking like a square. Now, this is going to be what? 90 degrees. If it's so, actually, it's a square. This is going to be what? 90 degrees. This is going to be equal to what? 90 degrees. This is going to be equal to what? 90 degrees. And of course, 90 plus 90 is 180 degrees. 180 degrees plus 90 degrees is 270 degrees. 270 degrees plus another 90 degrees equals 360 degrees, which tells us that sum of angles in a quadrilateral equals what? 360 degrees. But far beyond just this square, beyond just rectangle, we can have other quadrilaterals, which means that their angles may not be equal to what? 90 degrees each. But the sum of, irrespective of whatever the size of each angle that we are having in there, the sum of all of those four angles must always be equal to what? 360 degrees. That is what the sum of angles in a quadrilateral is saying. So let me take out these 90 degrees as we have them here. Now, I want us to derive something. There is a formula actually. Now let us see how each of these polygons that we see here, how their angles come about. The sum of their angles, how we come about them. Now, I'm going to be doing some drawings also. So we are going to be seeing them. Now, this is a quadrilateral. It has how many sides? 4 sides. 1, 2, 3, 4. I'm going to call it what? 4 sides. This one has how many sides? 1, 2, 3, 4, 5. Technically, in mathematics, it is called a pentagon. So it has what? 5 sides. 5 sides. All right. And this has 1, 2, 3, 4, 5, 6. This is a 6-sided polygon. Technically, in mathematics, it is called an hexagon. Now, that's what? 6 sides. Hexagon. Then for this one, may not look very fancy or beautiful like that as you may want it to be, but let's manage it as it is. How many sides? 1, 2, 3, 4, 5, 6, 7, and what? 8. So we have 8 sides, 8 wonderful sides for this figure. Technically, it is called an octagon. It is called what? An octagon. All right. So these are sides we have seen. Now, each of these things that you see here, they are called vertices. You call it igun. So they are called what? Vertices. So this is a vertex, this is a vertex, this is another vertex, this is another vertex. So in plural form, they are called what? Vertices. So I'm going to be joining what? These vertices together. I'm going to be using straight line to be joining one vertex to what? to the other, making sure that no two vertex or no two lines cross each other. No two lines cross what? Each other. So let me get my ruler quickly. Alright, so I'm here with my ruler. So I want to join this vertex to this vertex here. So let's see what I have. So I've joined this vertex to this vertex. If I try to join this other vertex to this vertex, you see that these two lines will now start crossing each other, and I don't want that to happen. Now, what do you see? This quadrilateral has been divided into what? Two parts. And those two parts that is divided into is what? They are, both of them are what? Triangles. So this is one triangle, this is another what? Triangle. So how many triangles are we having from it now? Two triangles. Two triangles when I join the vertex, all the vertices together. So I'm coming to these 5 sides. We'll be joining the vertices together. If I try to join this vertex to this vertex, it's just going to repeat this line to me. But I can join this vertex here to this vertex here. So let's join that. Alright, so we have gotten 1. Now this same vertex also, I can still join it to this other vertex here. So let's do that. Alright, now no two vertices can be joined together again without us having to what? Cross one line. And remember, we don't want to cross any line. So how many triangles have we been able to get out of this? 1, 2, and 3. So we're having 3 triangles here. 3 triangles. So instead of me writing tries, let me just write it like this. 3 triangles. I think this one will make sense better. This one gives us 2 triangles. 2 triangles. Then, for the third figure, how many triangles can we get joining the vertices? So, I'll be fast with that. I think these are all. No other one can be joined. If I try to join this to this, it's going to cross this line, which I don't want to happen. So how many triangles are we having? 1, 2, 3, 4. So we're having 4 triangles here now. 4 triangles. Then, for this one, how many triangles can we get? 1. Another line. Another line. Yet another one. Yet another one. So let's count how many triangles we're able to bring out of this now. How many? 1, 2, 3, 4, 5, 6. 6 wonderful triangles from here. 6 triangles. Okay, so we proceed to our next line of action. 2 triangles, 3 triangles, 4 triangles, and then what? 6 triangles. Now, let us see something that is unique among all of these shapes that we have brought out. This has 4 sides, 2 triangles. How do we get 2 triangles from 4 sides? That's going to be what? 4 minus 2. Let's put it that way. 5 sides, 3 triangles. How do we get it? 5 minus 2. That gives us what? 3 triangles. 6 sides, 4 triangles. How do we get that? 6 minus 2. That gives us what? 4 triangles. Now, How many sides are we having? 8 triangles and then what? 6 triangles. How are we going to get 6 triangles from 8 sides? That's going to be what? 8 minus 2. And of course, that gives us what? 6. Now you see, the number of sides has its own place. Then the number of triangles also has also have their own what? Place. Now, how many triangles can you get given the number of sides? You see that you are going to have 2 triangles less the number of sides. 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 And 2 triangles less the number of what? Sides, as you can see. Now, what if we are having n sides? N sides. How many triangles are we going to have in n sides? So the number of triangles that we are going to have for n sides is going to be what? N minus 2. N minus 2. Now, what is the sum of angles in one triangle? Sum of interior angles in one triangle is equals to what? 180 degrees. So ladies and gentlemen, if I am having 2 triangles here, this is going to be 180 degrees. This is going to be 180 degrees. Now 180 degrees multiplied by 2, what's going to be the sum of the angles? 360 degrees for this. 180 degrees, 180 degrees, 180 degrees. 3 of such, what's it going to give to me? 540 degrees. That's 3 multiplied by 180 degrees. 180 degrees, 180 degrees, 180 degrees, 180 degrees. How many am I having? 4 such triangles. So 4 multiplied by 180 degrees gives me 720 degrees, which gives me the sum of interior angles. 180 degrees, 180 degrees, 180 degrees, 180 degrees, 180 degrees, 180 degrees. So that's going to be 6 multiplied by what? 180 degrees for 8 sides. I don't know that for me. So I'm going to write that. 6 times 0, 0. 6 times 8, 48. Right? 8 carry 4. 6 times 1, 6. Plus the 4 I carry, that's going to be what? 1080. So that's 1080 degrees. So for sum of interior angles for an 8-sided polygon, it is what? 1080 degrees. Now, what if it is n sides? Of course, I haven't taken away your 2, which is 2 triangles less the number of sides. What are we doing, or what were we doing to get this one? We just need to multiply it by what? 180 degrees. And that gives us the formula for sum of interior angles of an what? N-sided polygon. Sum of interior angles of an n-sided polygon. That is sum of interior angles of polygons with n sides. All right. So I want to beg your pardon that it looks rough, kind of, on the board. But what I want you to get is the gist behind it, the intricacies behind it. I need you to enjoy mathematics, not to endure mathematics. So I hope with this little projects and escapades of mine, you are able to see how this formula came about. Sum of interior angles, sum of interior angles of polygons with n sides equals n minus 2 multiplied by 180 degrees. Thank you, and God bless you.